All right, so in this video, we are going to look at how to use Excel to solve some questions about binomial distributions, probability, a couple different types of probability. So here's the question we're going to work on. 55% of consumers prefer to purchase electronics online. You randomly select 8 consumers. Find the probability that the number of consumers who prefer to purchase electronics online is A, exactly 5, B, more than 5, and C, at most 5. So we have 3 different calculations to make. I'm going to go ahead and I'm going to open Excel. Okay, so for this one, we are selecting 8 people. And we're checking to see if they prefer to purchase their electronics online. So theoretically, I could have 0 of the 8 people choose to or prefer to buy their electronics online. There could be 1 out of the 8, or 2 out of the 8, maybe 3, maybe 4, maybe 5 out of the 8, or 6, maybe 7, or maybe all 8. Now I can't go above 8 because I'm choosing 8 people maximum, and I can't go below 0 because you can't have a negative number of people. So what I'm going to do is in each of these, the corresponding columns, is find the probability of each of these events. So what is the probability that 0 out of the 8 people prefer to buy their electronics online? Now I know the question only asked me for 5 or greater than 5 or less than 5 or whatever. This is going to be helpful to have the list out for these kinds of problems. If they only asked me what is the probability of exactly 5, I would probably jump right into it and just do that one. But because I know they asked me 3 different questions that require a little more calculations, I'm going to list out all these possibilities. And plus, it's going to give me some good practice using the binomial distribution function in Excel. So in my formula bar, I'm going to do equals, and I'm going to start typing binomial. And you can see it right there, binomial distribution, or binom dist, dot dist. And it's going to ask me first for the number s, the successes, which I have listed out. So for my first one is going to be 0. Then it's going to ask me for the trials. I have 8 total people that I'm interviewing or selecting. So 8. What is the probability? Our probability, according to the question, was 55%, which is 0.55. And then it's going to ask me for cumulative. And you can put in true or false. So we're going to put in false. You only want to put in true if you are specifically working with a less than or equal to question. And we're not going to do that right now. We're just going to do all of these as false to get each individual probability. So the probability of 0 people out of 8 liking to buy their electronics online is pretty small, which we'd expect. So I'm going to do this for all of them. So equals binom.dist 1, I'm on 1, trial is 8, probability is 0.55, and we're going to do false. We just want to do one probability at a time. Next one, 2, 8 trials, probability of success is 55%, and we're sticking with false. I'm going to go ahead and do all these. There's probably a faster way to do this, but I don't know, I think it's good to practice using these formulas. And the more you type it in, the more you can double check to make sure you're putting in the correct percentages, the trials. You want to make sure all those numbers match up. Just want to make sure we can spell properly. 4. This is probably really boring, but I have nothing interesting to say, so you can fast forward. I could always sing, but I think that would really drive people away. Let's not do that. I could tell a joke. I know some really good math jokes. Oh my gosh, okay. My favorite one is 3 logicians walk into a bar, and the bartender says, "Do you all want a beer?" And the first person says, "I don't know." And the second person says, "I don't know." And the third person says, "Yes." I love that joke. And there's those. What did I do? I had too many commas. All right, well, that's a good reason for not telling jokes while trying to type. I was going to tell the one about the Roman who walked into a bar and held up 2 fingers and said, 5 beers, please. All right, no more math jokes. We're almost there. 8. Probability, 5. Cumulative, no. Make sure I didn't mess these up while I was getting excited over my nerdy jokes. Okay. All right, last one. We are on 8 out of 8. Probability 0.55, and we are sticking with false. So we have all of the individual probabilities. Now, if they ask you for what is the probability that exactly 2 of the 8 preferred by their electronics online, we have that right here. It would be this one here. They asked us for the probability of exactly 5. That's this one right here. And if I round this to 3 decimal places, I get 0.257. So it's nice and simple when they want exactly 5 or exactly 2 or whatever. Exactly is nice. If they ask you for something like greater than, it's actually not too bad. That means it has to be greater than 5. So it could be the 6, the 7, or the 8, because those are all the ones in my list that are greater than 5. So that means it could be this one, or this one. And in math, or usually means add. So I'm going to add each of these up. This probability plus this probability plus. I'm just clicking each one to select the cell. Oops, that was the last one. And I get 0.220. And then the last one is find the probability that the number that prefer to purchase electronics online is at most 5. So that's 5 or less. So that means it could be 0, 1, 2, 3, 4, or 5. There's a couple of different ways to solve this one. We could do what we just did for part B, because it has to be less than or equal to 5. It could be the 5 or less, so it could be 0 or 1 or 2 or 3, etc. And like I said, or usually means add. So you could just add up each of these particular probabilities. All the ones that fit the criteria of being an event less than or equal to 5. I'm going to do that first. It's or equal to 5, so I can include the 5. And I get 0.77 or 0.780 if I round that. One other way I could have done this is because question B and question C are basically opposites of each other. They're greater than 5 or less than or equal to 5, and they're opposites. I could have, if I wanted to, I could have done equals 1 minus that one. Since they're opposites, we're working with complements, and I would get the exact same number, and that would work out. So either way works. And there is actually a third way you can do this one. Remember how I had you for each of these, when it asked you for true or false as far as cumulative goes, I had you put in false because that calculated just one single probability. And the only time you, as far as I know, would want to use true is if you had a less than or equal to problem, which we happen to have here. I could type in equals binomial distribution. It's 5 or less, so I would do 5, 8 trials, probability is 0.55, but this time I would type in true, because it's going to calculate this probability, probability that 5 out of 8 want to buy their electronics online, as well as all of the probabilities below it. So however you decide to do it, whether you add up the individual probabilities, whether you use the rule of complements, or if you decide to get fancy and use the binomial function, in all 3 cases, when we round to 3 decimal places, we get point, what did I say, 0.7780. And there you go. That's how you can use Excel to solve basically any binomial distribution problem. I'll have another video linked in the description that is made by math teacher and awesome math success coach, Amy Reagan. She does a lot of great videos. She's also given one about this topic for students to use. So I'll have that linked in the description as well. Hopefully this video was helpful, and I wish you the best of luck.